We are going to be having a look at 3D shapes and their properties. Let's first have a look at some prisms. We know that a cube and a rectangular prism or cuboid are prisms, and we now need to know the different terminology and the different parts of these shapes. So we need to know what a vertex is. A vertex is a corner. So there's a vertex, there's a vertex, there's a vertex. It's all these corners. A vertex is basically a point where two or more straight lines meet and it forms the corner of our 3D shape or our prism or our pyramid. Right, so when we are working with pyramids or cones, we have an apex, which is the topmost vertex of the cone or the pyramid. So just for now, with our prisms, we will only be working with vertices, which is the plural for a vertex. And we just need to understand that a vertex is a corner of the 3D shape. Right, we then need to know what an edge is. So an edge is that part there. It is basically all the sides of our 3D shapes. So an edge, it's a line segment that joins two vertices together. So as you can see, we've got a vertex there, we've got a vertex there, and those two vertices have been joined by an edge, which is a line segment that joins two vertices. Right, so there's our edge, and then we need to know what a face is. So a face is basically enclosed by our edges. So we can have a look at our cube here. There is a face. So there is our front face. And then we've got a back face, which is over there. And then we've got two sides, and we've got a top and a bottom as well. So a face is any of the individual surfaces of a solid object. Right, and then we need to know what a pyramid is and what a prism is. So basically, let's first have a look at our prisms, which we have here. A prism has two bases that are parallel and congruent to each other, which means that our two bases are parallel and congruent basically means the same. So we've got our cube here, which is a tricky example because all our faces are equal. So we can't really say that we have any particular face that isn't equal to another face. But if we have a look here at our rectangular prism or cuboid, we've got a face. We've got different options. So we've got a face there. So our two sides, there and there. Those two side faces are parallel to each other and they are congruent to each other. They are the same. And we could also use the example of the front and the back faces of our cuboid, or the top and the bottom of our cuboid, because all those opposite faces are parallel and congruent to each other. Right, and the thing with a prism is that the cross section has to be the same along its entire length. So basically, wherever you would cut that shape in half, the inside part of that shape that you've cut out would have to be exactly the same along its entire length. So that's what makes a prism a prism. Right, so let's now have a look at the properties of our cube. So a cube, we need to know in terms of our 3D shapes, we work in terms of how many faces our 3D shapes have, how many edges, and how many vertices. So now that we are familiar with these terms, we can figure out how many faces, edges, and vertices each of these 3D shapes or solids have. Right, so let's first work with our cube, which has, if we want to count our faces first, we've got a front face over there, which we've already pointed out, and a back face. So we've got a front and a back. So that makes up 2 faces. We then have 2 side faces, one there and one there. So that makes up 4 faces. And then we have a top face and a bottom, oh, where's it there? There's our bottom face. And so that makes up 6 faces altogether. So our cube has 6 faces. And if we would like to divide those faces into bases and faces, we would have 2 square bases. That could be our top face could be count as our base, and our bottom face could count as another base. So we've got 2 square bases, and then the front and the back face and the 2 side faces will be also 2 square, count as 4 square faces. Right, so those are our faces in our cube. Let's now have a look at the edges. We have got 1, 2, 3, 4 edges in our front. Then we've got 1, 2, 3, 4 at the back. And then we've got, so that counts as 8. Then we've got 9, 10, 11, and 12 edges altogether. So you just need to count very carefully, and remember, an edge is a line segment that joins 2 vertices together. Right, so now we've worked with our edges, let's have a look at our vertices. So our vertices, remember, are the corners, okay? It's where 2 or more straight lines meet, so it's where our edges meet. So we've got 1, 2, 3, 4, 5, 6, 7, 8 vertices. So we have got 8 vertices altogether in our cube. Right, let's now have a look at our rectangular prism or our cuboid. We again need to have a look at our faces. So how many faces are there? How many edges are there? And how many vertices there are. Right, so as you'll soon see, our cube and our cuboid have the exact same properties. So let's just prove that. So how many faces does our cuboid have? We've got a front face over there. We've got a back face over there. And we've got 2 sides. Okay, so that's already 4. And then we've got a top and a bottom base, a face as well. And that might count as our base. So we end up with 6 faces altogether. And we've got 2 rectangular bases and 4 rectangular faces altogether. So we just divide it up into, we do need to have at least 2 bases when we are working with our prisms, because remember, a prism has 2 bases that are parallel and congruent to each other. So we will have 2 rectangular bases and 4 rectangular faces. But remember, our bases are faces anyway. So you can just say that we've got 6 faces altogether if your teacher does not ask you for how many bases there are. Right. So let's now have a look at how many edges we have. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges altogether. So as you can see, that's the same as our edges for our cube. Let's now have a look at how many vertices we have in our cuboid. We've got 1, 2, 3, 4, 5, 6, 7, and 8 vertices in our cuboid as well. we are going to have a look at how many faces, edges, and vertices our triangular prism has, and how many faces, edges, and vertices our pentagonal prism has. So let's have a look at our triangular prism first. We know that a prism has to have two bases that are parallel and congruent to each other. So those two bases are also they are also faces in our prisms. So we need to identify those faces, which are also bases. So let's have a look here at this triangular prism. Our bases would be these two triangles over here. Because those two triangles are parallel and congruent to each other, and if you were to cut your triangular prism anywhere in between those two bases, you will get a cross section that is exactly the same as those two bases. So those there are your two triangular bases, and you will notice that the bases of your prism determine what the name of your prism is going to be. So because these two bases are triangular in shape, we will call this prism a triangular prism. And as we'll see when we are working here with our pentagonal prism, is that the two bases are pentagonal in shape. So they are both pentagons, our bases. And that is why we call this prism over here a pentagonal prism, because we name the shape we name our prisms according to our bases, so the shape of our bases. Right, so let's move back to our triangular prism. This triangular prism is upright. It is sitting on one of its bases. So let's have a look at how many faces this triangular prism has. We have got two bases, as we've already indicated. So here are two bases. They are triangular. There we go. So remember that your bases are also faces. So we've got two faces there. And then what we've got is, I'm actually just going to rub this out so that we can see more clearly where our rectangular faces are. So our rectangular faces are on the sides. So we've got one rectangular face there. Okay, you need to use your imagination. So pretend that you are looking at it from a different angle. There's a rectangular face there. There's a rectangular face over here that you can see slightly more clearly. And then I'm going to use a different color to show you the rectangular face at the back over there. So altogether we have got three rectangular faces and our two triangular bases, which are also faces. So altogether we have got 5 faces. 2 of those faces are our triangular bases, and 3 of those faces are our rectangular faces. So altogether we have got 5 faces. Right, let's now have a look at how many edges we have. So remember that our edges are the line segments that join two vertices together. So we have got 1, 2, 3, 4, 5, 6, 7, 8 edges there. So let's just have a look and just make sure. Oh, there we go. We've got one more. There's our 9th edge over there. So we end up having 9 edges in our triangular prism. So we know that we will have 3 edges in each of our triangular bases. And then, so because we've got 2 of those bases, we will have 6 edges immediately. And once we've realized that, then all we need to do is add 3 edges to count for the edges that join those 2 bases together. So we've got our 3 edges in each of our bases, and then those 3 edges that join those two bases together. So that's all together, that gives us 9 edges in our triangular prism. Right, so let's have a look at our vertices. We have got 1, 2, 3, 4, 5, 6 vertices in our triangular prism. Right, so there are your properties of your triangular prism. Let's have a look at the properties of our pentagonal prism over here. How many faces does our pentagonal prism have? Let's first have a look at our bases of the pentagonal prism. So if we would like to identify our bases, it would be this pentagon here. Okay, so there's our one base, and this pentagon over there. And the reason that those two pentagons are our two bases is because those two pentagons are equal to each other, and so they are congruent and they are parallel to each other. And those are the properties of our bases. So those two pentagons will make up our bases, and that is where we get the name pentagonal prism from, is because our bases are pentagonal in shape. So we've already seen that those are our two faces. Those are two of our faces. So we've then got a rectangular face over there that you can see quite clearly. So that makes up, so it's our two bases plus that rectangular face is 3. Then we've got 4, 5, 6, and 7 faces all together. Right, so we have got 7 faces in our pentagonal prism. 2 of those faces are pentagonal bases, and 5 of those faces are rectangular faces on the sides. Right, so let's have a look at our edges now. We have got 1, 2, 3, 4, 5 edges in our top pentagonal base, and 1, 2, 3, 4, 5 edges in our bottom pentagonal base. So altogether that makes 10, and then we just need to join our two pentagonal bases by these edges, 1, 2, 3, 4, 5. So that gives us 15 edges all together in our pentagonal prism. Right, let's have a look at how many vertices our pentagonal prism has. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 vertices in our pentagonal prism. We are going to have a look at these two pyramids and figure out how many faces, edges, and vertices these pyramids have. So this pyramid over here, this first one, is a square-based pyramid. So it's a square pyramid because our bottom here, our base, is a square. Right, so it could easily be a rectangle, so you would need to be told that it is a square, that the base is a square. Right, so this pyramid over here is a heptagonal pyramid, and that is because our base has 1, 2, 3, 4, 5, 6, 7 sides. So our base is a heptagon in shape, so we call this pyramid a heptagonal pyramid. So remember that prisms have 2 bases, whereas these pyramids have 1 base, and all the edges lead to a common vertex at the top of the pyramid, and that vertex over here is called an apex. Right, so that's how we distinguish between pyramids and prisms. And again, our pyramids and our prisms are labeled, so we name our pyramids and our prisms according to their bases. So this pyramid over here is called a square pyramid or a square-based pyramid because the base is a square. So let's have a look at how many faces our square pyramid has. We have got one square base at the bottom, which is also a face, remember? And then we have got one face there, which is triangular in shape. And we have got another triangular face over there. So that makes up 1, 2, 3 faces. And then I'm going to use a different color to show you. We have got another triangular face over there. So that makes up 4 faces altogether. And we have got another triangular face over there. Right. So that makes up 5 faces altogether. So we've got our one face at the bottom there, our base, our square base, and we have then got 4 triangular faces on the sides, or lateral faces we will call them. So we have got 5 faces altogether, 1 square base and 4 triangular lateral faces. Right. So let's have a look at how many edges our square pyramid has. So we have got 1, 2, 3, 4, 5, 6, 7, 8 edges altogether. And how many vertices do we have? Remember that an apex is a type of vertice, so we include that. We've got 1, 2, 3, 4, 5 vertices altogether in our square pyramid. Let's now have a look at our heptagonal pyramid. Our heptagonal pyramid has 1 heptagonal base at the bottom. So we've got 1 heptagonal base over there, which has 7 sides. We then have 7 triangular faces. So it's very difficult to see, but we've got 1 over there, 1 triangular face there, and it keeps going around and around. So you can play around with your heptagonal pyramids or your pyramids that have quite a big base at the bottom with lots of different sides. So you will find that you have got 7 lateral triangular faces around your pyramid, and then you've got your 1 heptagonal base at the bottom. So that makes 8 faces altogether. So you have got 8 faces in your heptagonal pyramid. Right. Let's have a look at how many edges we have. We have got 1, 2 at the back there, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 edges altogether. So we've obviously got our base, which has 7 sides in a heptagon. So we have 7 edges in our base, and then each of those vertices has an edge going up to our apex. So each of those vertices is 1 edge, which means we've got 7 extra edges going up to our apex. So we've got 7 edges, 7 lateral edges, and 7 edges in our bases, which makes 14 edges altogether. Right, let's have a look at how many vertices our heptagonal pyramid has. So we have got 1 vertice over there, which is our apex, or 1 vertex over there, which is our apex. Then 2, 3, 4, 5, 6, 7, and 8 vertices altogether. So we have got 8 vertices, and that is simply because we have got 7 vertices in our heptagonal base, And we've then obviously just got our one apex or vertex at the top. So we have got 8 vertices altogether in our heptagonal pyramid. We are going to have a look at a sphere, a cylinder, and a cone, and determine how many faces, edges, and vertices each of these 3D shapes have. Let's have a look at our sphere first. So we know that a sphere is a round object, so it is a round solid. So our sphere has one circular face. So our sphere only has one face. And remember that an edge is a line segment that joins two vertices together. But because we do not have any vertices in our sphere, because it is circular, it doesn't have any corners, we do not have any edges either. Right, so our sphere has one face, 0 edges, and 0 vertices. Let's have a look at our cylinder. Our cylinder is a solid that has 3 faces. So we've got our circular bases over there. And then we have got one face that joins those 2 circular bases together, and that is the middle face there. So we have got 3 faces in our cylinder. How many edges do we have in our cylinder? We have got 2 edges in our cylinder. Now this can be sometimes quite confusing because we do not have any vertices in our cylinder, but we do have 2 edges because our edges are where our lines meet. So our edges are not where our lines meet, our edges are where 2 faces meet. So if I just rub that out, we have got an edge over there and an edge over there because those 2 edges join this face over here with this middle face, and this edge over here joins this circular base or face with this middle face as well. So our edge joins 2 faces together. So even though we don't have any vertices, our edge still joins those 2 faces together. So that is why we have 2 edges in our cylinder. Right, let's have a look at our cone. A cone has 2 faces, okay? So we have got this circular base, and then we have got that face at the top. So we have got 2 faces altogether in our cone, and we have got one, or let's put our 1 there. We have got, yes, 1 edge in our cylinder as well, and that edge is the same over here. So there's our edge, and that in the same way with our cylinder, that edge joins our 2 faces together. So we have got 1 edge in a cone, and how many vertices do we have in our cone? We have got 1 vertice there, or 1 vertex there, because a cone is a type of pyramid, but we can also call this vertex an apex. So sometimes your teachers will accept either 0 vertices or 1 vertex when they are asking how many vertices does a cone have. So that just depends on your teacher's preference and how you have been taught. We are going to have a look at how many faces, edges, and vertices our sphere, our cylinder and our cone have? So how many faces, edges, and vertices do these solids have? Let's first have a look at our sphere. A sphere only actually has one face with 0 edges and 0 vertices. And that is because it is circular. It is a circular solid. So that would be exactly the same as our ellipsoid, which looks more oval. So it is a more oval circular shape, and it looks a bit like a rugby ball. So our ellipsoid, which looks a bit like a rugby ball, will also have one face and 0 edges and 0 vertices. Right, let's have a look at our cylinder. A cylinder has 3 faces. Okay, so our 3 faces are there. There's a circular base and there's our other circular base. So those are our 2 circular bases, which makes a cylinder a type of prism because we have got 2 circular bases that are congruent and parallel to each other. And then we've got this face in the middle. Right, so those are our 3 faces in our cylinder. And then how many edges do we have? We need to remember that an edge not only joins 2 vertices together, so an edge is also a line segment that joins 2 faces together. So in this case, we have got one edge over there because that edge joins this face and this face together. And we have got another edge over there because that edge joins this face and this face together. So we have got 2 edges in our cylinder. Right, how many vertices do we have in our cylinder? We do not have any corners in our cylinder, so our answer is 0 vertices. Right, let's have a look at how many faces our cone has. Our cone has 2 faces. We have got this circular base at the bottom there, and we have got this face over here. Right, because we have got an apex over there, or a vertex over there, or an apex, this makes a cone a type of pyramid. Right, so we've got our one base at the bottom there and our one face there. So that altogether we have got 2 faces in our cone. Right, let's have a look at our edges. How many edges does a cone have? Our edge over here joins these 2 faces together. So we have got one edge in our cone because that edge there joins our 2 faces together. How many vertices do we have in our cone? We have got 1 vertice there, but because this is also known as an apex, your teacher might accept 1 vertex or 0 vertices. So it depends on your teacher's preferences or how you have been taught.